Welcome back to lecture series on fundamentals of air pollution, sources, effects and mitigation. And here I am going to discuss little bit more about the aerosol cloud interaction and then some of the feedback mechanisms. Not much we can cover, but we will see that how much we can cover. So in the previous lectures I discussed about aerosols as CCN, and we discussed that some of the aerosols are very good CCN and some of them cannot be a good CCN. We talked about hygroscopic aerosols and hydrophobic hygro HYG and hydro. Okay. So this means these aerosols can act as CCN or they cannot act as a CCN. Some of the things, there are actually some biological particles, they are very important and they act as a very good CCN, like pollens, and then you have bacteria, you have viruses, fungus, algae, and then plant debris. These are very potential primary biological aerosol particles that act as a good CCN. Among the aerosols, I discussed that hygroscopic aerosols means water loving, and this means what will happen, they will try to attract water on their surfaces. For example, sulfate, nitrate and water soluble organic compounds, sea salts, they are very good CCN, they are usually very good CCN. But if you see particles like black carbon, dust particles, black carbon, although the black carbon size is actually very much, say 100 to 1000 nanometer or so, if you see the size distribution, the size distribution is very good for them to act as a CCN, but because of their hydrophilic nature, okay, these things, these aerosols will not be actually acting as a CCN. So this is very important. Similarly, dust particles are actually bigger in sizes and they are of course hydrophobic. They are not good CCN, but they are very good ice nuclei. So they can lead to the formation of ice nucleation. So this is another very important effect of these aerosols. Okay, and they have talked about that dust and sea salt, for example, sea salt aerosols, they can act as a CCN and IN particles. Now, how these marine primary biological aerosols are produced are sea spray. So you have a surfactant layer with the organics. So if you see in the ocean, on the top layer you have lots of organics that are actually there, and in the ocean surface, when there is a huge bins, these bins will interact with the waves that are there actually, that if you have happened to see beaches, you see waves are coming. When these waves coming, these actually sea spray aerosols there will be sea burst actually, or a burst of aerosols, and bubble bursting will be there. So this bubble bursting will produce sea spray emissions of sea salt and organic carbon. I mean organic be salt here, is mostly on the primary organic carbon, and this is actually mostly because we see here it is in the water form, it is actually in the soluble form. So this is actually in the sea spray, you will have like you can have sulfate, you can have like nitrate, okay, and you can have from organics you can have water soluble organic compounds. So they actually are coming from there. You also sodium and chloride particles, they are also very good hygroscopic in nature, they can also act as a CCN, but there is much of the research on these two are very less done, while these have been studied very frequently. So primary marine aerosols from bubble bursting mechanisms, and they are associated with the sea spray, correlated with the period of biological activity. So whenever there was a biological activity, and then sea spray aerosols or primary marine aerosols through so when there is a high chlorophyll, this means there is actually high biological activity, more of microorganisms are there, and if you see here percentage of organic matter that is there, and then if you see the concentration, they actually correlated well. So this means these times when the biologically active things were there, they produce very good CCN molecules. Now, let's discuss a little bit about the feedback mechanisms. So, climate change and air quality feedback loops, like it is look like this actually. So, when you have climate change, when we say climate change, we generally talk more than 30 years of time scale. And when we say climate, this is very different topics altogether. I cannot discuss much here. When we say climate change, so this means somewhere you have to discuss about the parameters which are related to the climate, and these parameters are actually temperature, relative humidity, water. Okay. So, you have warming or cooling kind of things, whether the humidity was there or rainfall patterns. These are the things that are actually preserved, and out of these actually temperature measurements becomes very easy, and then people correlated this climate change mostly in the terms of temperature. Otherwise, you can have other proxies as well, but when we talk about climate change, we generally talk about temperature because it is a very good indicator of climate change and it can be easily measured and linked with the processes. So, climate change can happen because of the natural forcings and long lived greenhouse gases. Natural forcing here means that the effects, for example, the distance from the sun and earth, the inclination of the earth with respect to sun. Okay, so with the inclination of the earth itself. So, based on that, the kind of natural forcing can change, and you have like tectonics activities and other things. In the long lived greenhouse gases, they are also actually, because when we talk about, because the climate is usually more than 30 years. So, any greenhouse gas which has more than 3 times of this one, say 100 years of time scale lifetime, then it can be talked about the climate change. But when we talk about the air quality, it is generally for a shorter time scale. In this case, the T is shorter, time scale is very short, and this case mostly it is related to the emission of the aerosols. And in the aerosols also we generally talk about anthropogenic aerosols. Yeah, so this is all about climate change and air quality feedback loops. Now, pathways by which aerosols could affect the South Asian monsoon. So, this is what is the feedback that can be there. I discussed about the precipitation formation and how South Asian monsoon can be affected because of the aerosols that is there in the atmosphere. Okay, and we know that we presume that aerosols are increasing here. Okay, they are increasing. So, there are 2 effects that are usually studied. One is actually solar dimming effects, and other is actually like elevated heat pump. Solar dimming effects, this was done by most of the experiments that were conducted in the Indo-X, and which led to the formation some sort of atmospheric brown cloud. Okay, and this is nothing but actually cocktail of air pollutants that are there in the atmosphere. When they are there, they appear as brownish in color. So, they call it actually atmospheric brown carbon. There was a very big issue on this one because initially they started calling this one as Asian brown carbon. Okay, then many of the researchers from Asia they said that it is not incorrect because this is not a phenomena that is happening in the Asia itself, it is happening everywhere. So, you cannot call this as a Asian aerosol, Asian brown cloud. This is actually, then it was changed to atmospheric brown clouds. So, the conclusion, aerosol imposed cooling on the land, okay, and northern ocean. So, when you have cooling on the land and northern ocean cools the surface, this stabilizes the temperature, reduces evaporation. Okay. So, these 2 things will happen. When this actually cooling happens, there will be more stabilization of the atmosphere. So, and then secondly, this will, because the radiation that is reaching on the surface is less, and if you talk about the surface is actually over the ocean, for example, it will lead to low or less evaporation. So, less evaporation means there will be less water vapor that is going in the atmosphere, and one less water vapor going in the atmosphere, this means they are going to change the radiative valence equations. And because these aerosols imposed cooling on the surface, they were called actually like solar dimming, because they are dimming the solar radiation that is there actually. So dimming means reducing the radiation, that is incoming radiation, and this can cause actually, this can affect the Hadley circulation, and this can also finally they can weaken the Indian monsoon or monsoon pattern. The second phenomena was much about the elevated heat pump, and heat means as the name says, elevated means positive or heating, and heat means energy somewhere has to be involved, and pump effect. Okay. So this was established, and this was mostly anomalous heating, mostly due to the black carbon, and these black carbons were found mostly, what are those black carbon? Mostly in the foothills of the Himalayas, and the warming of the upper troposphere over the Tibetan plateau caused transport of dust. So you have a warming of the Tibetan plateau, okay, because of these black carbon particles, and once you have warming, this you have more transport of dust aerosols, and this heats the atmosphere. Black carbon, they heat the atmosphere, making it unstable, okay, with the increased convection, and this results in advancement and intensification of Indian monsoon. So elevated heat pump effect did two things. One, actually it did the anomalous heating of the foothill due to the black carbon in the foothills of the Himalaya, especially in the Tibetan regions, and when this heating happens in that region, the atmosphere become less stable, and then there were lots of there was increased in the transport of dust aerosols, and not only dust aerosols, the adjoining regions, sea, for example Arabian Sea, and so they bring lots of monsoon in this one. So they can have actually modification of radiative valence. So atmospheric stabilization by absorbing aerosols, mainly black carbon, modification to the surface radiation and flux, as we discussed, positive radiative forcing because of the aerosols. Extensive aerosol plumes may modify regional circulation pattern. For example, if these aerosols are there, dust can be transported higher altitude sites in the Himalaya, and this has in fact has been found actually, that there were lots of aerosols that were found in the Calypso. They found lots of dust aerosol particles at higher altitudes, and this leads to the weakening of the Indian monsoon. So this is actually there are two things that are correlated actually, this weakening of the monsoon and then intensification of the Indian monsoon because of the weakening of the monsoon happened because of the modification in the radiative valence because of the black carbon aerosols. Okay. Yeah, this is very this distribution. I think somehow the picture is not shown. So distribution of the black carbon absorbing and solar heating over the Tibetan plateau. So how might aerosol chemistry affect the precipitation? So this picture you can see here water clouds in summer, and you see water clouds in the winter season. What you see here in the two pictures, you see a kind of and we discussed, of course, let's first we talk about the first indirect effects or Tommy effects, that was modification to cloud microphysical properties, suppression of auto conversion or warm clouds, suppression of auto conversion into warm cloud, and then modification of microphysical pathways for growth of precipitation and associated feedbacks. This we discussed actually, okay, in the previous slides, that these pathways can modify the microphysical properties through modification in the microphysical properties. This growth of the precipitation can be affected, and then with that the associated feedbacks can be affected. So Tommy effect is not very special to soot only. Actually, Tommy effect is common for aerosol as well actually. So it is general phenomena, but soot has been used because soot is having a more pronounced effect. So this will lead to more ion particles but smaller droplets, okay, this due to this Tommy effect, you can have more ion particles, but will you have a smaller droplets particles, the particle size will be smaller, or ice crystal. Okay, a cloud affected by Tommy effects appear brighter and is actually unaffected by the counterpart. Okay, so because the same amount of water are dispersed to more particles and has bigger optical effects, larger optical thickness because of the more scattering and reflection. And then secondly, because you have now increased number concentration and increase CCN. Okay, so CCN increase is there, you have alpha is more reflection, and this means when you have more reflection, this size, droplet size will reduce, and then it will not be actually critical, it will not be able to reach the critical size. There will be, this means there will be a less precipitation. Okay, and this is our increase in cloud lifetime. The cloud that is found, it may not precipitate, or it may precipitate after a long time. And this is what is shown here in a very clear things. You have unperturbed aerosols, you have direct effects we discussed, just in a nutshell. If you see here, this is actually direct effects of aerosols and aerosols, scattering and absorption. So you have, and indirect effects, actually undisturbed cloud, you have unperturbed cloud, you have good CCN, and you have sufficient droplet size which is surpass the critical size. So this means it can be lead to the precipitation. On the other hand, you have a increased CCN but a smaller droplets. So there is a increased cloud droplets number concentrations. Okay, but and then cloud albedo effects. So this means this will not be precipitated. There will be decrease in the cloud size. So more N, more increase in the aerosol particles, more CCN, but there will be a reduction in size. And then what will happen? There will be not be any kind of rain, but there will be a kind of drizzle kind of things will be there. And then this is actually what will happen. This will also, because it will be reflecting more, this can increase the cloud height as well actually, as well as because the droplet size are very small, they will not be able to precipitate. The droplets will be lingering on the clouds for longer time until they are becoming a very kind of of that critical size, surpass the critical size, so that they can be precipitated out. Okay, so this is actually indirect effects on the, this is actually called second effect, or Albright effect also it is called. So and then not only that, if this is actually some aerosols which are I talked about, for example black carbon, if they are there, they can not only re-radiate that one, they can further reduce in size. So heating can cause cloud burn off. So this is very actually important. This is also called semi-direct effect. Okay. So now the question we are ending, had the aerosol monsoon cloud puzzle been solved? I think there were lots of papers they talked about, but and they identified some of the possible mechanisms by which the aerosols can affect the monsoon over South Asia, but there are caveats in each of these studies, and still we are having like lots of things that has been ignored. For example, indirect effects of aerosols has been ignored in studying this precipitation or monsoon, Indian summer monsoon. Aerosol distribution, for example in Lau et al., Neal et al., they needs to be evaluated based on the observations. So the aerosol distribution were mostly modeled one, and they needs to be evaluated based on the observations over the regions. Magnitude of and distribution of ABC forcing, aerosol brown cloud forcing, does not show good correlation with recent data available over the land areas with this region. So this has to be still. So although there are some advancement in the aerosol monsoon cloud understanding or climate interaction, climate understanding, but the puzzle is still not solved. Okay, and in the future, indirect effects and climate feedback mechanisms for secondary aerosols, secondary organic aerosols needs to be considered, and they have to be actually brought into the picture, because these secondary aerosols, they are actually very good CCN. This is very important, and because of this CCN they can actually activate the cloud formation, and not only that, they can then affect this cloud albedo and air temperature. If you see, and then in this process, if the air temperature is affected, their emission will be affected, so they can change this emission, and then through the emission of volatile organic compounds, if the emission is changed, which is precursor to secondary organic aerosols, the secondary organic aerosols will be filled. So this is actually kind of complete in circle. Okay. So we should better understand how aerosol affect cloud formation and precipitation. We must know how cloud droplets are formed. This is the fundamentals. We really don't know, especially effect of aerosols and cloud microphysics, forming smaller and more numerous droplets. Aerosol dynamics, hydrological effects, direct, semi-direct and indirect effects, modulate radiation, thus perturb the atmospheric circulation. Some of the questions like how global warming will affect CCN activation and climate in the changing scenario needs to be understood. Yeah, and not only that, apart from that, primary and secondary organic aerosols, they are the main routes for the in the marine boundary layer. So if you see here, these can also lead to the particle, like species like new particle formation, where this can actually affect the secondary organic aerosol formation, and then through which actually condensation and then liquid phase reactions, they can affect this primary and secondary organic aerosol partitioning, and then primary organic aerosols containing sea spray, they can be affected. Surface film which contains dissolved organic carbon and particulate organic carbon, they can be affected with this one. So by degradation of the organic surface films and emission of light molecular weight metabolites. So this process has to be understood. Primary and secondary aerosols has to be understood. And finally, the consequence of global warming, the negative effect, like when you have more global warming, the temperature will increase. This means what will happen? The plant will release more of volatile organic compounds, and they will be oxidized to respective scattering aerosols, which is mostly secondary organic aerosol we call it. This means you have more reflection of sunlight and hygroscopic growth. So more scattering means cooling, and then it will help in hygroscopic growth in forming the clouds and cool the atmosphere. Yeah, this is very important. But what about other species like nitrate, sulfate and ammonium? The thermodynamic equilibrium between ammonium nitrate has to be considered. Oxidation of these species needs to be considered, that how actually the oxidation process is going to change this one. And not only that, the positive feedback mechanism. So this is actually a negative feedback mechanism. Negative in terms of this one, because we are talking that in the scenario of global warming, the temperature of the atmosphere will increase. This is we have assumed that when the temperature is going to increase, and then we discuss the consequences of the increase in the atmospheric temperature, like how it is going to how they are going to affect the volatile BOCs, biogenic BOCs, and then their oxidation to the secondary organic aerosols. And you have more secondary organic aerosols, means more CCN kind of aerosols, so they will be reflecting more. But at the same time, what will happen? So you are adding more of scattering aerosols. So this means your droplet size will try to decrease or will reduce. But the point here to consider is that although the particle size will decrease, but these are hygroscopic aerosols, so there is a chance that these particles can help in growth of the aerosols, and then through condensation and other processes. So you can have actually kind of precipitation in that one. Okay, so you can have more precipitation, but on the other side, because of the increase in number of particles, a smaller number of droplets will be formed, so we will have kind of reduction in precipitation. So these effects are still not very clear actually. So these are the things that has to be considered, and then some of the other species like that are there in the naturally, that are anthropogenic emissions, because we know because of the anthropogenic emissions, NO2, this like you have already increase in NO2, we have increase in SO2 concentration. So these are the precursors for their gases. And use of fertilizers in the agriculture, and especially the kind of fertilizers like urea, which gives huge amount of ammonium in this ammonia, they are going to produce more of secondary inorganic aerosols. They are going to give secondary inorganic aerosols. These are actually could be a good CCN, okay, because they are hygroscopic, but at the same times their number increases, means this size of droplets that is going to decrease, and this means less precipitation again, okay. So hygroscopic, if you just consider, more CCN formation will be there, but that need not necessarily be lead to the formation precipitation, and then oxidation of other species can be there in the atmosphere. Positive feedbacks, global warming will lead to again increase in the temperature, that is well definited. This means you have more evaporation from the water bodies. This is very important. So more evaporation means from the water bodies, this means you are going to add more water vapor in the atmosphere, okay, and which is actually a potential greenhouse gas, which may further lead to an increase in the ambient temperature. So this process can also happen in that way. Another thing is very important, that when you are increasing water vapor in the atmosphere, you increase the water vapor in the atmosphere, all those particles which were actually liquid water, this means you are going to increase the liquid water content, and this means liquid water content per CCN drop is also going to increase. Now this important point that was lacking, that because of the this less liquid water reduction in the liquid water content, the cloud size was smaller. Now you have enough liquid water content, or you have increased liquid water content, the droplet size can be further increased. So when the droplet size increases, you can have actually more kind of precipitation. So yeah, it is actually kind of both ways. We really don't know which way it is going to act. As a scientist, this is very promising research questions that needs to be understood, and we really don't have answer at this moment that how these aerosols are going to affect our systems, or especially the precipitation. So thank you, take care.